All right. Hey, today, or this video is about the why are they picking on short people, right? We're looking at roller coaster loops. Oh, that person right there. Are they experiencing something different than someone that is a different weight? Ultimately, when we do, or when there is a design for roller coasters, there is a minimum speed. Okay, there's a minimum speed by design where all of a sudden you do not feel a force. Okay, this is the weird part. So if I were going to do a free body diagram, and this is a person, what are our forces? And this is the weirdest free body diagram. If I'm going on a roller coaster and I'm on a seat, which way is my normal force? Right? So here's the seat and here's my butt. The seat is pushing down. I've got my normal force. I can feel it on my bum. Okay? Well, which way is force of gravity? Right? Force of gravity is also this direction. It's the weirdest, most I guess, confusing free body diagram ever. But ultimately, there is an imbalance of forces, right? There is no upward force. It's all downward force. So that means there is a net force towards the center, right? There's a net force towards the center of motion. It would be towards the center of motion here, center of motion here, although with some gravity, you'd have your center directed and some gravity, so maybe it's just a little off center. So that's why we look at the top position, okay? We look at that top position and this net force, but what we're trying to find is that minimum speed, and that minimum speed is where I've got this centripetal force right here. And minimum speed is when there's no tension, but it stays in that circular force. So on this ball, you've got a tension keeping it in circular motion, but what if a tension goes to zero? The tension is keeping that ball in circular motion. This normal force is keeping you in circular motion. So the minimum speed comes up with a force normal. Right, force normal equals 0. So the question is that minimum speed for a really heavy person? Is that heavy person going to fall out first? Or is that light person going to fall out first? Right? Remember, the signs don't ever say you must be this heavy, right? That's not why we would have this little symbol there, right? It's about height, not about weight. Okay, so I'm just going to do the Newton's second law equation with centripetal force. So net force, right, centripetal equals mv squared over r. That v squared over r is a definition of that centripetal acceleration. Maybe I can scooch it up just a little bit. Okay, and what are my forces? Well, this is actually where I like to say my acceleration is down, right? So I'm going to say down is positive. So force normal plus force of gravity equals mv squared over r. Well, force normal goes away because we're finding minimum speed. Who's going to fall at first? It's going to be a heavy person or a light person. Force of gravity equals mg, mass times little g, which is 10 newtons per kilogram. This is the mass of the person. And the mass goes away. So my minimum speed, g times r, is the square root. So v equals the square root of g r. Now I know you're going a little algebra crazy right now, okay? But what impacts the minimum speed, I'll put minimum here, right? That minimum speed is when all of a sudden you are not making contact with the seat anymore, okay? And that's acceleration due to gravity, 10 meters per second squared, or 10 newtons per kilogram, times your radius. So the radius has everything to do with setting your minimum speed. Okay? So why do they have, instead of weight restrictions, it doesn't matter. If I've got this minimum speed, the lightest person is going to fall at the same time the heaviest person is going to fall, right? If I drop two different mass items, they fall at the same rate. It's the same principle, heavy or light, minimum speed, they fall. Even the cart itself would fall at that minimum speed. It's all about the radius and this. So what's the height have to do with it, right? The height is really more about the restraints that go over the shoulders, right? So the person has to be a certain height so that they can be in those straps like the Patriot, right? Or the bar itself, right? I have my legs, the bar. If I'm too short, my legs don't provide that appropriate restraint or strap in the cart itself. So I hope this gives you a little insight, the physics behind it. I'm not going to make you do the physics behind it, but I want you to see this principle of minimum speed and how it works itself out with Newton's second law. And maybe, just maybe, you'll think about it when you are riding the Mamba or the Patriot and going upside down. All right? Have a good day.